All right, example 2. I'm going to start off here with an asterisk. When using the law of cosines, always find the largest angle first. Now, this is going to help us because in quadrant 1, cosine's positive, but in quadrant 2, cosine's negative. So if I'm cosine inversing the positive angle, the positive ratio, then it will give me the quadrant 1 angle that I need. If the ratio is negative and I cosine inverse it, then it's going to give me the quadrant 2 version, which is the obtuse version of the angle. So cosine will return to me either an acute or obtuse angle, depending on the ratio. Because sine is positive in quadrants 1 and 2, then you don't get that same type of help in terms of finding the angle. You need to be able to know this. So law of sines, find the smallest angles. Law of cosines, find the largest angles first. So the largest side is 19 feet, so that means B is the largest angle. So we're going to go ahead and take B is equal to, we go up to our formulas, it's the cosine inverse of, and it's a squared plus c squared, so it's 8 squared plus 14 squared minus 19 squared over 2 times 8 times 14. Now, if we take a look at this here, 8 squared comes out to be 64, 14 squared is 196. So 196 plus 64, somewhere right around 260. 19 squared is 361. So you can see that this whole numerator is going to go negative. The denominator is positive, which means the ratio is negative. So the cosine inverse is going to return to me a quadrant 2 angle. Now, you don't need to know that. This just works itself out. So let's go ahead and take a look at what that becomes. So cosine inverse of, now we've got to be careful here with the fractions, okay? Because what's inside is a fraction. Either A, use the fraction key, and if you don't like that for some reason, then make sure you wrap your numerator in parentheses. So that's the way I'm going to do it right here. So we have 8 squared plus 14 squared minus 19 squared. Close the numerator, divided by, open the denominator, 2 times 8 times 14. And we get 116.8 degrees. Now, at this stage, you can either choose to switch and use the law of sines to find angle A or C, or you can stick with the law of cosines. I just want to show you, since we're using calculators, I want to show you the advantage to sticking with the law of cosines. All right? So to find angle A, we would use, so to find angle A, these are the two sides. So we're going 14 squared plus 19 squared minus 8 squared over 2 times 14 times 19. So watch this now. That means if I go back to my calculator and I hit second enter, it brings back exactly what I typed. So what I'm going to do is come back here. The 19 squared is positive this time. The 8 squared is negative. Now, this is something that is difficult for a lot of people. We need to insert. So I put the cursor over the 8, and I want to put something in front of it. So I hit second, delete, which changes the cursor to just an underline. And when I hit something, it slides everything to the right one. Now, what's hard for people to remember is this. When you write a negative number squared, the calculator performs the operation of squaring the exponent before negating it. So negative 8 squared written this way will return negative 64. So this negative does do the job of the subtraction. If I were to wrap the negative 8 in parentheses, then of course it would give me positive 64. All right, so now I go down to the other end and I want 2 times 14 times 19. So I'm going to change that 8. I'm going to put a 1 in there to replace that. Now I need to insert a 9. And I get 22.1. And at that point, angle C is just 116.8 plus 22.1. And we subtract that from 180, and I get 41.9 degrees. So again, the law of cosines, always find the largest angle first. Once you do that, the other two are going to be acute anyway. So whether you use the law of cosines or the law of sines, either way is good enough. I'm going to go ahead and finish this video with doing Heron's formula. This is a way to find an area of a triangle given the three sides, A, B, and C. We're going to start by finding something called the semi, which means to have something. So we're semi-perimeter. So this means find the perimeter, A plus B plus C, divide that by 2. We're going to call that S for semi-perimeter. And then the area of that triangle is the square root of that S times S minus each side. So it's S minus A times S minus B times S minus C. So it's a pretty nice formula. It's not hard at all. It's just difficult probably to remember it. But you start, in this case here, we have the three sides. And so I'm going to find the semi-perimeter by adding 43, 53, and 72, dividing that all by 2, and we get 84. Once we do that, the area is going to be the square root of 84 times 84 minus 43 times 84 minus 53 times 84 minus 72, and that comes out to be 1,131.89 meters squared, or square meters. All right. So with that, you should be able to complete the Delta Math assignment. I wish you the best of luck with it.